Okay, this is Mac 1105, Chapter 3, Section 5, Part 2, Transformations. This is the last part of Chapter 3. This deals with reflections. This is example 9 in your book, which is on page 260. You can see right here that we have the x squared graph. You can see I have 0, 0, negative 1, 1, 1, 1. A reflection across or about the x-axis, which means that this whole graph is just going to flip down, is when we have a negative in front of the whole function. So see how the negative is in front of all of the x squared, not just the x. So what happens is this affects the y's. So we multiply this by a negative, we get negative 1, negative 1. We multiply this y by a negative, we get 1, negative 1. Multiply by 0 by a negative, but of course we get 0. So anytime you have a negative in front of the whole function, it's a reflection about the x-axis, and all the y's change sign. Second type of reflection we have, and this is example 10 on page 261, deals with reflection about the y-axis. Okay. And this is where a graph is going to flip over the y-axis. On the black mark, we have f of x equals square root of x. We have our 0, 0, 1, 1, 2, 4. That's just plugging the numbers into here. Oops. Shoot, I got that wrong. I'm sorry, I mismarked that point as 4, 2, not 2, 4, because the square root of 4 is 2. Alright, so what happens here is when we put the negative directly in front of the x. Notice this is different than the one up above where the negative is in front of the whole x squared. The negative is in front of the x. It's not outside. So what this does is affect the x's. So we multiply this 0 by a negative, of course it's 0. Multiply this 1 for the x position, and by a negative we get negative 1x. Multiply this 4 by a negative, we get negative 4, 2. So see, a reflection across about the x-axis, you're multiplying all the y's by a negative. A reflection across the y-axis, you're multiplying all the x's by a negative. In the textbook, on page 261, there's a chart, which I'm showing you right now, which lists all the different transformations. You have the vertical shifts, the horizontal shifts, the compressing and stretching, reflections, and that's all there is to it. Let's go through example 13 in the textbook. In example 13 in the textbook, and if you look at example 13 in the textbook, you have f of x equals square root of 1 minus x plus 2. All right, so the first thing you need to do is you need to make sure that you put it in a form that you can read. So here's the same equation, f of x equals square root of 1 minus x plus 2. All I did was bring the negative x in the front and, of course, a plus 1. So now I can see my transformations. I can see that I got a vertical shift up 2. I got a horizontal shift to the left 1. And then I got a reflection, which is going to be about the y-axis. Okay? So this is what's going to happen when we solve this graph. So here's basically what happens here. Okay, and I'm going to get kind of close so you can see these, and I'll just move it. So here is the square root graph. And incidentally, this is on page 263, example 13. And so here we have our 0, 0, our 1, 1, and our 4, 2. So this is the parent function. First thing we deal with is the plus 1 inside the square root. Well, the plus 1 in the square root is really a minus 1. So what we're going to do is we're going to subtract 1 from all the x's. So when I subtract 1 from here, that 0, 0 becomes a negative 1, 0. Subtract 1 from here, that becomes a 0, 1. Subtract 1 from here, that becomes a 3, 2. We then go to the negative, which means we're going this in front of x, which means we're going to reflect. Remember what I said before, that negative in front of x multiplies times the x's. So in terms of this, we multiply this negative 1 by a negative, we get a positive 1, 0. Multiply 0 by a negative, we still get 0, 1. Multiply this 3 by a negative, we get a negative 3, 2. And so we can see that this graph is flipped over. Last thing we deal with is a plus 2. This is a vertical shift. And remember, on a vertical shift, we add whatever the number is to the y's. So what we do is we add 2 here, so we're at 1, 2. We add 2 here, so we're at 0, 3. We add 2 here, so we're at negative 3, 4. And this is what I want to see. I'm not necessarily concerned with the process coming from here, but I want to see how the 3 ordered pairs from the parent function become new ordered pairs in your transformation. Last thing I want to point out is this is example 12. And this is a tough one. This is the reciprocal function. And in the reciprocal function, the big thing is you got to recognize that this 3 over this x minus 2 plus 1 represents 1 over x. And then the minus 2 represents a horizontal shift to the right, 2. This is a vertical shift up 1. And then this multiplies times all the x's to give us that vertical stretch. I just wanted to point that out to you. I am not going to give you any problem on a test dealing with a reciprocal function.